All right, guys, section 4.3, and this is known as a right angle theorem. Okay, here's the theorem, Theorem 23. If two angles are both supplementary and congruent, I don't care how you draw them. So hypothetically, let's just say that I am drawing two angles, angle A and angle B, and they are supplementary, so they add up to 180. But they are also congruent to each other. It has to be true that they are both 90 degrees. Okay, so if you run across two angles, and most of the time these two angles are going to be adjacent or next to each other. So for example, angle ABC and angle CBD. They're obviously supplementary. Angle ABC plus angle CBD are supplementary. Those are our windshield wiper angles. If you find out that they are also congruent to each other, then they have to be right angles. Okay, that's what the theorem says. That's the right angle theorem. So if you come across two angles and you can prove to me that they are supplementary and you can prove to me that they are congruent, then they are both ABC and CBD are right angles. Okay, so if you can prove to me they are supplementary and congruent, then they are both right angles. I know it seems very obvious. I'm going to show you guys in a proof. Okay, so I'm trying to prove that AD is an altitude. To prove something is an altitude, it must start at the vertex and hit the opposite side at a right angle. Again, start at a vertex and hit the opposite side at a right angle. So let's go ahead and write down the information that we have. So step one, and we're probably going to try and get the triangles congruent. AB is congruent to AC, and that is given. So we know this triangle is isosceles, which we might need to use. We have BD is congruent to CD, and that is also given. And then from here, again, if you'd like to use angle B congruent to angle C, because if two sides are congruent, the angles are congruent. Or I think the easiest way is to go the third side. I think most of you guys would see that. And that is the reflexive property. Any segment is congruent to itself. Therefore, triangle ABD is congruent to triangle ACD. And that is by side, side, side. Okay, why did I choose to make those triangles congruent? Well, I chose that so that I can get these angles congruent to each other. Because not only are they going to be supplementary, but if they're supplementary and congruent, then they are right angles. So I'm going to say angle ADB is congruent to angle ADC, and that is because if triangles are congruent, then their corresponding parts are congruent. Okay, I'm also going to state in here angle ADB is supplementary to angle ADC, and that is because if two angles form a linear pair, and that's assumed from the diagram. Okay, if two angles form a linear pair, then they are supplementary. Okay, once you have these angles congruent and supplementary, okay, congruent and supplementary, go back up here, you know that they have to be right angles. So angle ADB and angle ADC are right angles. Okay, and that is because if two angles are congruent and supplementary, then they are right angles. And why do we care that they're right angles? Because now AD has to be an altitude, because if a segment from a vertex, which is what so many of you guys forgot on your test, if a segment from a vertex of a triangle is perpendicular to the opposite side, and it formed right angles, then it is in altitude, okay? Proving the right angles is enough. If you'd like to add a step in saying that the segments are perpendicular because the right angles are formed, you can absolutely do that. Too much information isn't always wrong, okay? So giving me additional information is perfectly fine. But again, when I saw that I had to prove something was an altitude, I knew I had to prove that there were right angles. And the only way for me to prove that there are right angles is for the angles to both be supplementary and congruent. How else are you going to prove angles are right angles? Okay, we will cover this next example in class.